Bismillahirrahmanirrahim. Assalamu alaikum students. This is our third lesson in continuation of our discussion about unit number 6, which deals with the concept of work and energy. Interconversion of energy. We know that energy can neither be created nor destroyed, but can only be converted from one form to another. Consider an example of log of wood. When it is burnt, chemical energy gets converted into light and heat energy. It means processes in nature are a result of energy changes. Consider a simple example of interconversion of energy in water cycle. Heat energy from the sun is absorbed by water that is present in oceans, rivers, lakes and streams, which causes an increase in the thermal energy of these water molecules. The increase in thermal energy causes the water molecules to evaporate. As these water molecules evaporate from the surface of water bodies, they possess kinetic energy as they move towards the atmosphere. Upon reaching the atmosphere, the kinetic energy possessed by these water molecules gets converted into potential energy as these water molecules condense and form clouds. When it rains, the potential energy of water molecules gets converted into kinetic energy as the rain drops. This rain water may reach a lake, dam, river or a stream. As this rainwater flows down, the kinetic energy of rainwater gets converted into thermal energy, while some of the kinetic energy of flowing water is used to wash away soil particles of rocks, which is called soil erosion. Major sources of energy. They are divided into two main types: non-renewable energy sources and renewable energy sources. Let us first understand what do we mean by non-renewable energy sources. These are the energy sources which are present in limited quantity. It means that if their use is unchecked and uncontrolled, they may vanish entirely from the surface of Earth. Non-renewable energy sources consist of fossil fuels and nuclear fuels. Fossil fuels such as coal, oil and natural gas are basically compounds containing carbon and hydrogen, also known as hydrocarbons. Fossil fuels took millions of years for their formation. Their use is increasing day by day to meet our ever-increasing energy requirements. So, it is crucial that we use them wisely and also develop new energy sources for our future requirements. Fossil fuels release harmful gases upon combustion. These gases are responsible for various health and environment problems. Nuclear fuels. Nuclear power plants use fission reaction to produce nuclear energy. Fission reaction is basically the splitting up of heavy atoms such as uranium atoms into smaller parts, resulting in release of large amount of energy. Some part of this energy is used to run nuclear power plants, whereas remaining energy is just released into the atmosphere. Renewable energy sources include energy from water, sun, solar house heating, solar cells, energy from wind, geothermal energy, and energy from biomass. These energy sources will not run out like coal, oil, and gas and can be used again and again. Energy from water. Using water for power generation is the most economical method. Dams are built at suitable places to produce electrical energy all around the globe. These dams serve the important purpose of controlling floods by storing water. The stored water in the dams can be used for irrigation and power generation. Energy from sun. Sun is the most important source of light and heat energy. Without sun, life on earth would not have been possible. Solar energy is used directly and indirectly to meet our energy requirements without polluting the environment. Solar house heating system. The use of solar house heating system is not new. However, their commercial use is quite recent. A solar house heating system consists of a collector, a storage device, a distribution system. A solar collector is made up of glass panels over blank metal plates. These plates serve the purpose of absorbing sun's energy, which heats a liquid flowing in the pipes at the back of the collector. The hot water thus obtained can be used for different purposes such as cooking, washing, and heating the buildings. The solar energy can also be used in solar cookers, solar distillation plants, and solar power plants. Solar cells. Solar cells are also called photocells. They convert light energy directly into electricity. They are made up of silicon wafers. When large number of solar cells are wired together, they form solar panels. They are used to power lighthouses, telephone booths, and satellites. Energy from wind. Wind is an important source of energy. Wind powers sailing ships across oceans. It causes windmills to grind grain and pump water. When large number of wind turbines are installed on wind farms, they produce enough power to operate a power plant. Geothermal energy. Hot, molten part deep inside earth is called magma. When water flows close to this magma, it gets converted to steam due to high temperature of magma. This steam is then used to generate electricity. Geothermal wells can be constructed near hot rocks at places where magma is not very deep to obtain this useful form of energy. Water is then pushed down into the well. The rocks quickly heat the water and change it into steam. It expands and moves up to the surface. The steam produced can be piped directly into houses or offices or can also be used for generating electricity. Energy from biomass. Biomass is plant or animal waste that is burnt as fuel. When animal dung, dead plants and dead animals decompose, they produce a mixture of methane and carbon dioxide. This methane produced can be used to generate electricity. Mass energy equation. Einstein predicted the interconversion of matter and energy, which means loss in mass of a body will produce a lot of energy. E is equals to mc square is the famous mass energy equation, where m is the mass of the body and c is the speed of light, according to which it appears that mass is a highly concentrated form of energy. The process of interconversion of energy is taking place on the sun and stars for the last millions of years. Only a fraction of sun's energy reaches us towards the earth. This very small fraction of sun's energy is responsible for life on earth. Electricity from fossil fuels. Given is the block diagram of electricity generation from fossil fuels. As is evident from the block diagram, the chemical energy stored in fossil fuels is used as input energy. The heat energy generated by burning fossil fuels is used to produce high pressure steam in a boiler. The potential energy of the steam produced is used to turn a turbine, which causes mechanical energy from turbine to run an electric generator. Electricity is the final output from an electric generator. Energy and environment. Different energy sources, although being very important and inevitable, are the cause of many environmental problems such as air pollution, water pollution, and noise pollution. Pollution is defined as a change in quality of environment that can be harmful or unpleasant to living things. Thermal pollution is the rise in temperature of the environment that disturbs life. Volcanic eruptions, dust storms, forest fires, burning of fuel, and solid waste add pollutants to the air. Waste heat and dangerous radioactive waste produced by nuclear power plants, when released into oceans and rivers, upsets the balance of life in them. Governments and individuals can help reduce these harmful effects by reducing use of cars and other machines that burn fuel. Carpooling and using different public transport services can effectively contribute to reduction in pollution of our environment. Figure shows the energy conversion in case of an electric lamp. An incandescent lamp uses electrical energy as input, which gets converted into light energy as output and heat energy as output. Figure shows the block diagram of a vehicle running with constant speed on a level road. The fuel in a car is a source of chemical energy, which gets converted into heat energy, kinetic energy, and sound energy when burnt. Ignition of fuel in the piston of engine produces kinetic energy, which gets converted into work done in moving the vehicle, which is an output. Figure shows the block diagram of energy conversion in case of a power station. Potential energy of stored water in a dam is a source of input energy, which gets converted into kinetic energy of flowing water with the release of heat and sound energy. The kinetic energy of flowing water produces heat and sound energy in addition to doing work done in running the turbine. The running of turbine also produces heat and sound energy. Work done in running the turbine produces electrical energy from electric generator. Electric generator also releases heat and sound energy as output. Efficiency. Efficiency of a system is the ratio of required form of energy obtained from a system as output to the total energy given as input. The formula for efficiency is required form of output divided by total input energy, or in case of percent efficiency, we can write required form of output by total input energy multiplied by 100. Ideal system. An ideal system is a system whose efficiency is 100%, which means that the output of an ideal system is equal to total energy used by it. Please remember that practically no system is 100% efficient, because in a practical working system, energy obtained in the required form is always less than the total input energy, because in every practical system, energy losses such as heat and noise due to friction occur. Power. Power is defined as rate of doing work. Mathematically, we can write power is equal to work done by time, or P equals W by T. The SI unit of power is watt. The definition of watt is: the power of a body is 1 watt if it does work at the rate of 1 joule per second. It means we can say that 1 watt equals 1 joule per second. Bigger units of power include 1 kilowatt, which equals 10 raised to power 3 watts, and 1 megawatts, which equals 10 raised to power 6 watts. Please note that there is another bigger unit of power, which is known as horsepower. 1 horsepower is equal to 746 watts.